Before we begin talking about different types of chemical bonding, it is necessary to know and understand the Octent Rule. In basic terms, the Octent Rule states that atoms tend to form compounds in ways that give them 8 valence electrons, which is the electron configuration of a noble gas. Atoms want to form compounds in this way because this is the most stable electron arrangement. Ionic bonds usually take place between a metal and a nonmetal. It entails the complete transfer of valence electrons between atoms. Ionic bonds generally generate between two oppositely charged ions, which then are attracted to each other, forming an ionic compound. In ionic bonds, the metal typically loses electrons between a positively charged cation, and the nonmetal typically accepts those electrons to become a negatively charged anion. An example of an ionic compound is sodium chloride, or table salt. Sodium and chlorine form an ionic bond because sodium has 1 valence electron and chlorine has 7 valence electrons. Therefore, sodium wants to get rid of 1 electron and chlorine wants to gain 1. So, sodium gives its 1 valence electron to chlorine, making chlorine a negatively charged anion, and making sodium a positively charged anion. Then, since opposites attract, they form the ionic compound NaCl. Covalent bonds, also known as molecular bonds, are between nonmetals. Covalent bonding entails the sharing of valence electrons rather than the complete transfer of valence electrons seen in ionic bonds. Each pair of shared electrons is called an electron pair. If atoms share 2 pairs of electrons, we can say they are double bonded. If they share 3 sets, we can say they are triple bonded. The atoms are held together because they both pool on the same electrons. We represent these bonds like this for a single bond, this for a double bond, and this for a triple bond. An example of a molecule formed by a covalent bond is H2O, or water. We can represent the covalent bonding with the Lewis structure. The 2 molecules on the left and right side on the top of the oxygen atom represent 2 electrons that aren't being shared with the hydrogens. These lines each represent 1 electron for both hydrogen and oxygen, and they represent the covalent bonding between the 2. Another factor in covalent bonding is electronegativity. Electronegativity is a measure of an atom's ability to attract shared electrons to itself. Basically, atoms with a higher electronegativity attract the shared electrons in a covalent bond more than the atom with a lower electronegativity. This impacts atoms and molecules because it will cause atoms with a higher electronegativity to have a partial negative charge, and those with a lower electronegativity to have a partial positive charge. And these partial charges impact the properties of the molecule formed by the atoms. We can represent this partial positive charge with delta. We can also represent the partial negative charge with delta. In this example, hydrogen has the 2 hydrogen atoms have a lower electronegativity than the 1 oxygen atom. Generally speaking, as we move up and to the right on the periodic table, elements' electronegativity increases. A final type of bonding is metallic bonding. As opposed to ionic bonding, when metal atoms bond with other metal atoms, they don't gain or lose electrons. Metallic bonding is the main way that metal atoms form bonds between each other. In metallic bonding, the metal atoms are bonded by their electrons, which form a sea of electrons around the positively charged atomic nuclei.